So, have you ever tried principle of mathematical induction before?
Yeah, I did it in high school.
Yeah. So it's similar to that. So the points which you have to follow while solving all those questions. Step number one, you always need to substitute n as 1. Step number two, you have to assume that it is, you have to check it whether the expression is true for n 1, and then you will assume that yes, it is true for n equals k, and then you will see whether it is true for k plus 1. If it is true, that means wherever you find out k, you have to make it k plus 1. If you find that out, then you will say that by principle of mathematical induction, this is true. Okay. So for
Yeah.
instance, the first question, the exercise 2, which you have given to me, it is that 7 divides 3 raised to the power 2n plus 1 plus 2 raised to the power n minus 1. That is, this part is divisible by 7. This you have to prove, right?
Yeah.
So how would I do that? It's simply if I check it for n equals 1. So you will say that let us check whether the expression is true for n equals 1. So you'll say, forget about this, the main dividend, 2 plus 1 plus 2, 1 minus 1. So 3, 2 was a 2 plus 1, 3 plus 2 raised to the power 0, right? So it is
Yeah.
what? 27 plus 1, which is 28.
Yes. Which
And
is
7,
divisible by 7.
yes, hence you can assume it as Pn. So Pn is true for n equals 1. And then you will assume that, let us assume in the step 2, that Pn is true for n is equal to k. So if it is true, that means if you substitute in place of n k, it will give you some factor of 7 where q can be any integer, right?
Yes.
Now, if this is the case, I need to come up with something which is k plus 1, and then I need to take out 7 as common and see whether it is making the factor or not. So need to show that pk is true for k equals k plus 1. So on the left hand side, I'll substitute it k plus 1, and then I'll bring, in place of k, I'm putting k plus 1, and I'll bring that 7 times something. So let's see, 2k plus 2 was a 2, and this is it. So 3k into 3 raised to the power 3, right?
Yes.
What else can be done here? If I have to uh, make it 7, and then I have to take something common also. Uh, if I make it, let's say, if I keep it, if I keep it 2k plus 1 and take out this, because base same power added, power gets added, so you can separate them this way. Is this fine? I have kept this one as it is and 2 separate. If you do the
Yeah. Okay.
reverse engineering, it will give you the same value. Now, what is the benefit of this step is, if I I know 3 square is 9, and I can write 9 as 2 plus 7. right?
Yes.
I need to bring 7 into picture.
Oh, okay, right.
So, if I now distribute it from here, these two have same bases at least. So can I take out common anything? So what I
Yes, you
did,
can just keep
uh,
the power of k plus 1 minus 1, and then keep the minus 1,
hmm,
and just put the 2 in brackets.
right. Let's try that. 3 raised to power 2k plus 1 into 7. Here I'm taking 2 common, so what is left? 3 raised to power 2k plus 1 into 2 raised to power k minus 1, right?
Yeah.
Because if you do this, if you distribute, this is it. And if you distribute this one, you will get this, right? Base same power at 2 raised to power 1 plus k minus 1 will be 2 raised to power k only, right?
Yes.
Now what can I do? I know if you see this 3 raised to power 2k plus 1 and 2 raised to power k minus 1, what is it?
It's the same as k, and you know that that's divisible by 7. So the second part of the equation is divisible by 7.
Yes. By PMI. So you can take out 7 as common.
Wait, what's
And then
PMI?
principle of mathematical induction.
Okay.
So we are trying to induce something by observation or by putting in the values and to see whether it is, can we make a general formula out of it? So this is 7m where you will write that m is 3 raised to power 2k plus 1 plus 2q. So this is 7m. Hence, 7 divides, or it was 3 raised to power 2n plus 1 plus 2 raised to power. What was it? N minus 1. Is this fine?
Yeah.
Similarly, if you try to solve another question, what it was. Are you jotting this down or you will refer to?
No, I've written it down. Like mostly I knew how to do it, but this one was a little
Yeah.
bit different. I haven't done this specifically before, so I got lost.
Okay. Let's now try next one, which is consider the limit wherein limit n tends to infinity minus 1 raised to power n cos n square plus 1 upon n plus 1. And you have to tell me which one of the following is correct, that its value is 0, limit diverges, value is 1, or limit diverges but not to infinity. So firstly, you can see I have minus 1 raised to power n, which you know is the oscillating function. Sometimes it give me negative value, sometimes positive. Yeah.
Yes.
So it will always alternate between -1 and +1. And then you have this cos, and if you want to find out the nature of every part, first is -1, which is oscillating between these two values. Second is cos value. And I know cos is, if you see cos 0 is 1, cos 90 is 0, right? And all those values always lie between these two, right?
Yes.
So it is oscillating between minus 1 and 1. And is this a bounding function or not? Do you know what a bounding function? Upper bound, lower bound, they have the limit. The upper limit
Yeah.
or lower limit up to which it can extend. So I know the value if the value is lying between minus 1 and 1. So of course, the function has to be bounded. And then I have n plus 1. Can you see? Because n is tending to infinity, it will always be an increasing function.
Yeah.
And if it is increasing and reaching out to infinity, that means it is without bound. It is growing like anything. It doesn't have upper limit.
The denominator, so shouldn't it be a decreasing function like overall?
Yes, yes. Overall, it would be. So if I have to say that the question is asking what is happening? Is it converging to a particular value or diverging, that's spreading like anything? Or the exact values are 0 or 1? So
And
you'll consider,
convergent, it has a limit, but divergent means it does not, right?
yes, yes. So
Okay.
now, if you consider, I have the whole thing, but I would like to focus on denominator first. What do you think? I know that denominator is changing sign. So if it is changing sign and one time it is negative, another time positive, is it totally increasing? No, it is not diverging then. Are you getting my point?
Yes.
You will write that this sequence does not diverge. Why? Because even sometimes you're getting negative value, sometimes positive value. So it is restricted to that. It is not, if it is increasing also, it will again move back to this. And n plus 1 is making it smaller.
How do you know it's
And
minus 1 to the power of n?
how do I know what?
How do you know it's minus 1 to the power of n?
This is in the question.
Okay. So, but then it goes to minus infinity and positive infinity, right?
It is n tends to infinity. So if I have to check whether it is a continuous function or not, then we use left hand limit and right hand limit and the function's value. So we'll write that n tends to h minus some sort of thing we consider. Then it goes from negative value to positive. Now here, what has happened? Now here, what have I got? Why it's flipped? So I have minus 1 raised by n. In order to tell whether it is diverging or converging or whatever, I need to see throughout numerator and denominator where the function is heading towards. So that's why I'm just finding out the nature. Even if you will say that, okay, if your n is increasing, then you can't say that your function is increasing because denominator has n plus 1 and it is also reaching towards infinity, right? And
But
if
that
both
means the
of
overall function is decreasing.
decreasing, yeah, and decreasing means it will turn out to or tends to 0 someday, because out of 4 options, one would be considered as an increasing value, some sort of thing, positive, very bigger value, and diversion is
Right.
not happening. So we are left with this, right?
So it has to be converging, right? Or not?
Yes, I mean, it is tending to 0. So you will say, yes, the value is decreasing. So it is converging towards 0. Okay.
Okay.
Then we have another question, which is,
Just to check, the only situation when you can select the answer as diverging would be when it's just continuously increasing or continuously decreasing functions.
yeah,
Okay.
yes.
Because
Then
then they
you,
would not have a limit. They would just go on towards an infinity or minus infinity.
correct. It should be having the infinite value that it is going on and on and on. Okay?
Right, yeah.
Boundless. Then I have another thing which is limit n tends to infinity. What should I do with this? I need to, so it is not about diverging or converging. I need to find its value actually. What do you think? How can we approach it? So, huh, tell me.
Would you have to use like the definition of a limit to solve?
Basically, that would not help because I have this square root. I need to get rid of this first. Then I can think of any other thing. So let me try rationalizing it and see where I'm heading towards.
Oh
So,
wait, you can just multiply and divide with n squared minus 1 and all of that in the square root, right?
yeah, I mean, if you take this out common, so let's separate this. This is actually this, right? Yeah.
Yeah.
So now if you rationalize, and that too, I have, okay, you can separate it as this bit also. Now you can, if you have to rationalize, what can you do? Just focus on the root part, this one. So that will be, you multiply it by plus n, right?
Yes.
So this will give you what? It is a minus b, a plus b. The formula would be a square minus b square, which is this square minus n square, right?
Yeah.
And it will remove the square root. Yes.
Yeah.
So n square is gone. So I've got this here, right? So that means now the question has become limit n tends to infinity. I'm placing this value here, minus 1, right?
Yes.
Now what can I do with it? Now you have to separate and see whether it is an increasing function or where it is heading towards. So if you substitute n infinity, why I've done this? Because, when you have infinity limit, it would be better if you can get n or its higher powers in denominator, because 1 by infinity is 0 only, right?
Yes.
So it would be better, even if you have something in denominator, something like um, n square or something. So you can take out n square common so as to make it this way. Yeah. N square plus 1. Let's say this is 1 plus n square. So you take out n square and make this form, because then you have 1 by n square as if it is limit n tends to infinity. This will be 0, and this, though I have to check because 0 by 0 I can't form. I need to separate it or factorize it or whatever. But you try to make it, the common thing which you should get is 1 by n form, 1 by n square form. Okay? Yeah?
Yes. Yeah.
So now where's the question here? Actually, this is my question. So what should I do with it? Can you see root n square plus n? If, what do you think if n is, as n increases or as n growing, because n is tending to infinity, closer to infinity or approaching to infinity. Don't you think that n square plus 1, because n is increasing like anything, and 1, that means n would be bigger than 1. So you can neglect 1, and you can say that it is almost equal to n square, so n, right? Can you say so?
Yeah.
And if it is n, so this has become n plus n, 2n. Yeah,
How
because
did you get rid of the plus one though?
uh, so 1 is way less than n because n is increasing
Oh,
to
because it's
infinity.
so small, it's
It's so
basically
small. Yeah.
inconstant. Yeah.
So I have assumed that leave 1, it will not make any sense even if we add it. It will not make any difference. So then square and square root get cancelled and I got n. And when I substitute n back, n plus n is what? 2n. Is this fine?
Yes.
Now you know if you substitute. Now the question has become 1 by 2n minus 1. And now you can simply, easily and freely substitute n as infinity because you know 1 by n, 1 by infinity is 0. So the answer is minus 1. Is this fine?
Yes.
Okay. So this was literally critical to think that, okay, rationalization. You know, if you want to think whether it is PMI or this limit question, the trick is for PMI, you have to make the k plus 1 in such a manner. For example, it was 7 times something. So try to make it 7 form. When it is limit, just try to make it 1 by n form if n is tending to infinity. Because if, see, if n is tending to 2, and if it is 2 upon x minus 2, I can't simply substitute x as 2 because 2 minus 2 will give me infinity form, 2 by 0, not defined form. I need to come up with something else. So if it is n minus 2, then what should I do? I should take n as common. And as soon as I take n common, now I can substitute. What? If I substitute n as infinity, so 2 by n, that is 2 by infinity, and here 1 minus 2 infinity, sorry, 2 into 1 by n, I know it is 0. Correct? 1 by infinity, I have 0. So the answer is 0 now. 0 by 1, that is the defined form. Are you getting my point?
Yes.
Okay.
Wait, so just to go through it, it's when you simplify it using all those calculations, you get limit when n goes to infinity 2 over n times 1 minus 2 over n. And 2 over n, when you put in infinity, is basically 0. Then it's 1 minus 0, which is 1. And then infinity times 1 is infinity. And then 2 over infinity is, again, basically 0. So that's how you get it goes to 0, right?
Basically, infinity is 1 by 0 form. So 1 by infinity, if you reverse, it will be 0 by 1 form. Now, I have considered that this is, I
Wait,
have made
infinity by 1 is 1 by 0? How?
infinity. What do you call it? I mean, if you have an answer, infinity, we call it not defined form. So one
Oh,
infinity
right.
is something which is going on, and one of the infinite thing is like 0 by 0, 0 by infinity, infinity by 0. All these stuff, when you have denominator as 0, those are consider as infinite forms, infinity value, indeterminate form, what you call it. So for that, you have to make 1 by infinity so as to get 0, a rational number. 0 I don't want in denominator, but in numerator form. Is this fine?
Yes.
Next question. I have limit n tends to infinity, 3 plus 2 by n, 3 minus 1 by n. It is saying show by using the definition that this is 9. What do you think it should be?
Actually, we can
Yeah.
skip this question. We solved it.
You know this?
Yes, I solved it.
Okay. On to the next one, which is let fx be root x, and you have to prove using the definition that limit x tends to a fx equals root a if a is greater than 0. Again, it is tending to infinity. A is greater than 0. I don't know the upper bound. So by definition, I need to say if fx is root a and x is tending to a, if fx was root x, then fx is root a also. So, if I have to find out the value for limit, if this is the question, let's say, I can simply put down the value of the limit and I'll get the answer. If it is not in the indeterminate form, right?
What do you mean indeterminate form?
Indeterminate form means 0 by 0 form, infinity form, 1 by 0 form, all those infinity by infinity form. These are not defined or indeterminate form.
Right. Yeah.
So if I'm getting an answer which is justified and which is within the range of real numbers, then I simply put down the value and get the answer. So if this is the case, fx is root x, and I know that x is tending to a, so I can simply put down the value and I'll get root a, right?
Yeah.
Because it is not giving me any infinite form. This I have to prove using what? The definition or simple proof. So what you can do, you will simply start by writing the definition that if x gets closer to a, I mean just translate this, not this one. If x gets closer to a, then that means root x has been changed to root a. Root x also gets closer to root a. This is what I have to prove. So if I see, I can take any value by the difference or by the addition, like root x minus root a if I choose. Only if I am having a as infinity, then only it becomes indeterminate form, right? The
Yeah.
condition is a is greater than 0. If I can consider that, okay, no matter it is greater than 0, but it has an upper bound. It is not that big that it is reaching to infinity. Then I can say that limit exists for this. right? So if I prove that a is actually lesser than infinity, a is not infinity, it is very smaller value, then I'd be able to prove it. So for that, what I'm doing, I have taken both of the functions like fx when it is root x, when it is root a. I'm trying to build a relation that yes, this root a is very small. How? Let's take the conjugate part. This is root x minus root a. The conjugate is I'm multiplying it with the conjugate means with the opposite signs. Is this
Yeah.
fine? Just to get rid of that root value from the numerator, and we'll see what to do with denominator. So this is a plus b, a minus b, so a square minus b square. Is this fine?
Yes.
Now when I add this, it can help me with the denominator. If you are adding something, this root a is getting added to root x. So of course, if a is greater than 0, then x also has to be greater than 0 because that means a is closer to x. Is this fine?
If a is more than 0 and x is more than 0, then
Denominator value will be too large and you will say the whole fraction is too small.
so again it could go to 0.
Yeah, so it is
But
very
isn't there the
small.
possibility that x is really, really big and a is like 1?
So that's what I'm trying to prove, that a and x are almost closer to each other. And how I'm doing it? Because I have rationalizing, not rationalizing because we have not gotten rid of the root from the denominator, but we have taken the conjugate by multiplying and dividing. So I can see that this x minus a, if a is anything which is in the denominator, let's not talk about x, but because root a is greater than 0, then denominator is going to be greater, right, than numerator. Yes or no?
Yeah.
Because if a is greater than x, then this is of course getting minus, subtracting in numerator. Subtraction is there in numerator. Denominator is getting bigger and bigger, right?
Yes.
So now if denominator is getting bigger, then the whole fraction is smaller. Can you say that root x plus root a is of course greater than root a? This is
Yeah, because
the
obviously
only
they're
thing.
being added and it has to be positive, otherwise you get complex numbers. Yeah.
Also, because root is a number, and here on the left hand side, you are adding x to it. So this is giving it more weightage, right? Onto the left hand side.
Yeah.
So if root x plus root a is greater value than root a, that is also making it smaller. Again, this value is getting smaller. You can give this as one of the scenarios wherein you are trying to prove that this value wherein you are getting the denominator is bigger than the root a value, and which is making this numerator form smaller. And if it is smaller, if your fraction is coming out as smaller, what does it mean? Because your a is greater than 0, this is given. But your smaller value of fraction means x is also smaller. X has to be smaller, then only the fraction can be smaller, given this condition that a is greater than 0.
Yeah.
So that means what? X is smaller, a is smaller. So I can say that this is not going to give you indeterminate form. Where's the question gone here? This is not going to give you indeterminate form. So this question can simply be done by substituting x as a, and hence fx is root a. Is this fine?
Yeah,
This is,
is that it?
yes, this is one way of doing it. Otherwise, you could give this reasoning also. As you know, for a continuous function, limit exists. Limit exists. What does it mean? That left hand limit is equal to right hand limit is equal to the function itself.
Yes.
So the square root function is actually the continuous function. So you will say that because this is a square root function which is continuous, and so the limit exists. And if limit exists, we can substitute it simply in the question, and I'll get fx is equals to root a. If this is a short answer form question, then you can do it this way also. Is this fine?
Yeah.
All right.
But
Huh.
like we were taught to do it with the delta epsilon.
Okay.
I just want to see how you should do it in that because they check our method and that's how we're supposed to do it.
Okay. So for that, there is a neighborhood. If I have a point, I have a limit, let's say, if it is going from A to B, you consider epsilon wherein, I mean, any number, you can say this is A minus something. For that, you can consider the value that this is A plus epsilon. Okay. If you are going this way and this is B minus epsilon. So epsilon is
Because
the
there's an
neighbor.
upper and a lower bound.
Sorry.
Because there's an upper and a lower bound.
Yes. There is an upper
Okay.
and lower bound, and we have the neighborhood wherein it is very small collection, but yes, this is a range, has smaller values, wherein the LHL and RHL, the left hand limit, right hand limit, they are getting satisfied. Now, what will happen? I mean, this definition, it is definitely something theoretical. You have to say that, let's say there is an epsilon, which is always a greater value, because your limit is also given as greater. So, greater than 0, you assume that for any such epsilon value, which is greater than 0, you can find another value, delta or whatever, which is greater than 0. So definition says that if this happens, that means it is happening in this manner, that 0 and delta. These are two ranges in which that function is lying, the absolute value of the function lying. Then the value, if you have to substitute this as fx minus root a, this is lesser than epsilon. This is what the definition says. So definition says if you are considering more than 0 values and you know that limit changes if it is x greater than a, and if you change the sign of the values, you multiply them with the negatives, then the sign of inequality changes, right?
Yes.
So if you are getting having this fx minus root a, then this has to be lesser than epsilon. This is
And
what
fx is root x. So you could also write root x minus root a is modulus
correct.
of that is less than epsilon.
Yes, this is what you have to consider. So you are starting with the concept that, see, I have this question and I'm making it very smaller so that it is not reaching out to infinity or infinite value, okay?
Yes.
So again, you will apply that conjugate thing in the next step, wherein you have this value and you will, what we were having earlier, it was this x minus a upon root x plus root a, okay? So you have that, this conjugate thing, and now try to bound the denominator as well to see that, okay, no, it is not boundless, it is not increasing like anything. It has the upper bound. It is smaller than a particular value. So how can you bound if consider some value? So I need x near a. Though a is greater than 0, but can you make it a smaller value? Can I say that x a is greater than 0, but can I make x in relation with a? Can I say that x, let's assume x is greater than a by 2. I'm assuming x is somewhat near to a and I want to give it a bounded value. So I'm assuming half of x is actually, there is a, there is x, and there is some value a by 2 lesser than a here. So I'm assuming that x is greater than a by 2. So as to get it into the relation that, okay, somewhat a will also come into picture, okay? I
Yes.
can assume any of the values in the neighborhood. You could have assumed a4th also, a8, whatever. So if I substitute here, it is going to give me root x minus, it was actually, yeah. So root x, if you have to substitute here, what was it? The denominator I'm trying to bound, okay? Denominator I'm
Yeah.
trying to bound. I have in denominator root x plus root a. So if I substitute, it is also greater than if I substitute x as a by 2. It is going to be increasing if I place it in the increasing order. Of course, if I have root x plus root a and x is greater than a by 2, then I can place it here, right?
Yes.
And of course, this is going to be greater than root a.
Yeah.
Now, if you have to compile these inequality, you can consider the numerator value also when you have this absolute value, which you assumed that this is actually this value because of the conjugate. And then this is this value because denominator is greater than this. So the fraction will be lesser than this. Yes or no?
Yes.
So then you will say that, okay, now bring that definition into picture that if you have x minus root a, which is lesser than epsilon, because you have to say that it is lesser than delta. This is what you have to prove. So if it
Yeah.
is lesser than epsilon, that means this value is equal to this one. That means x minus a upon root a is lesser than epsilon, right? Then you
Yes.
can bring this root a onto the right hand side. This will give you some sort of this. So you can choose delta anywhere in the neighborhood of e root a. So you can say that you can consider
Wait,
any.
but in the step before, when you have absolute value of x minus a divided by root x plus root a is less than absolute value of x minus a divided by root a. Where did the root x go?
So basically, if you have this, I brought this from here. Am I audible?
Yeah.
So if you see, I have root 2 plus root 3, and here I have only root 2. So of course, this value is going, it is more than the right side value, right?
Yeah.
And if I now change it to fraction form, then the sign will change. Because now denominator, if denominator gets decreased, then fraction increases. If I have 2 and 4, I know 4 is greater. But as soon as I flip them, now I know 1 by 2 is greater, right?
Yes.
So this is how if I have this value, increased value, bigger value, but in denominator. So the fraction which is having lesser value than this, keeping this thing in mind that numerators are same, that fraction will be greater, right?
I don't get it.
See, you have this. Initially, you had x minus a upon root x plus root a, right?
Yeah.
Just at the moment, don't see the numerator. If here you have root a, of course, this is greater, right? Left side.
Yes.
Because it is only root a here, but it has something adding to it, which is also a positive number. So it is, of course, greater. Now, if you make it a fraction form in which numerators are same, now this will be bigger because its denominator is smaller, right?
Yes.
So that's how I had this inequality facing rightwards as the greater value. Is this fine?
Yeah.
So once you get that, and you flip it, take this root a to right hand side. Now you consider delta. At the moment, you have this value here. This is the order x a by 2a. Now you consider delta, which is somewhere in between this value also you've got. So you can have delta in between these two. You can say that it is minimum. You can take any of the minimum value and get your answer minimum than that. So you will say that, oh, it is not boundless. It has a boundary. Are you getting my point?
Yes.
So you are saying that minimum of a by 2 or epsilon root a you can take. And then you will say that if you know that absolute value is going to be this way, right?
Yeah.
And your value x and a has this relation. This x minus a is less than a by 2. That means x is greater than a by 2 is greater than 0. If a is greater than 0, a by 2 is also greater than 0 by 2, that is 0.
Shouldn't it be x is less than a by 2?
No, I considered this way here.
Wait, can we go through it from the start? I don't understand.
Okay. Let's do it again. So first up, did you get the definition part?
Yeah.
So I need to bring into picture the delta, and that delta has to be lesser. Okay, so I'm starting with the question. I have root x minus root a. This is my function. And its absolute value, the positive value is also less than epsilon. If its absolute value is less than epsilon, that means epsilon is definitely going to be greater than 0, right?
Yes.
Now you have that conjugate value, which is root x minus root a is equal to x minus a upon root x plus root a, right?
Yes.
Now you have to bound the denominator. You can assume anything. You have to assume x nearby a. As you know, a is greater than 0 and a is greater than 0. This is absolute value. It is going to give you positive value only. So x also has to be greater than 0. Can you consider x as 0 is here, a is here, x somewhat here. I know A is greater and X is smaller, but I can still make it X is greater than A by 2, right?
Yeah.
Now, if you have that, what it will give me? Root X plus root A. I can substitute the value of X as root A by 2. Still, it is going to be bigger because A by X is greater than A by 2. So this is the satisfied condition.
Wait.
You have,
But how do you know that X is more than A by 2?
because I have assumed it that X is near to A is greater than 0. I have taken half or 1/4, anything you can take.
Yeah.
But X has to be greater than that so as to have this absolute value in the picture.
But you don't even know yet that A is greater than A, that X is greater than A.
Yeah, so this is sort of left hand limit, right hand limit. So you can consider, you are assuming this, now assume that X is greater than A by 2. You are considering it in the neighborhood of A. So what you are doing, even after having an increasing function, you want to limit it to a particular value so that it will not give me an indeterminate form, right?
Yeah.
So that means what you are having, you are considering X as the higher value only, but you don't know whether you can't actually consider X as A, because this is what you have to prove, that root X is root A only. So you have considered half of A or 1/4 of A, and you have assumed that X is greater. Why greater? Because the more the value you are having, and in spite of the fact that the value is more, you are making the function bounded. Okay?
Um,
See, you have to prove fx is root x. You have to prove that fx is actually root a.
yeah.
And this limit is x tends to a, right?
Yes.
So x is approaching towards a. So I'm not assuming that a is lesser because x has to approach to a. So that means a is bigger. Okay? But
Yeah.
can I at least assume a number which is lesser than a, but for which x is greater? That I have assumed that, let's say it is a by 2. You could have assumed any number, and in spite of the fact that this is just to shorten or simplify the values so that I would not be having many variables. You could have assumed any integer also, let's say x is greater than n, where n is integer, and we'll see the relation of n with respect to a later.
Yeah.
So,
I'm just confused that you don't know yet that X is more than A. So how do you know that X is more than A by 2? Like,
yeah,
how
I
can you just
know
assume that?
I have assumed, for example, this has to be in the neighborhood. If I have to go towards A, then I need to find out a value which is not lesser than what I can't make this as. It is, of course, lesser than A, but I have to bring it to make it a number here, which I have assumed. For example, you can say x1, wherein x is greater than x1. Would that work? You consider greater value. You have to consider greater value only. Why? Why not lesser? Because you want to show that it is reaching out to infinity, but still it has an upper bound. And
But
bounded
then you can
function,
also assume that x is more than x1, right?
x is more than x1. Yes, you can assume.
But can you also assume that a is more than x, or is it only x is more than a?
No, at the moment a is more than x because x is approaching towards a. And I have root x. I can't have x as negative value. So it has
Okay,
to be
okay.
absolute value.
Wait,
Okay.
if x is approaching to a, how is x more than a? Because it's coming to a value that is as large as a.
No, I'm saying a is greater than x at the moment, but x is greater than half of a. Because it is,
Right.
I'm assuming that, okay, see, this is the circle. The radius is a. X is coming out somewhere here, here, here. So I'm assuming that x, this much is a by 2. To, to make it more proximal value, I mean to show the proximity, I've assumed that x is here and it has passed more than half of the path. It is that closer to a.
Yeah.
I'm making it closer to a. So the value which is nearby a, you have to assume that x is greater than that. Then only you will be able to show, you will show that, okay, x and a are almost similar and root x is root a now. Okay.
Yeah.
So now, if you have assumed that x is greater than a by 2, you can simply substitute the value here. In place of root x, you have root a by 2 because you are using this sign. You have kept everything same. Only if you substitute the lesser value in place of x, then only you are getting greater than inequality, right?
Okay.
But this is denominator. If it is denominator, that means if I have the fraction in place, this
Mm-hmm.
fraction, root x plus root a, this will become smaller than that value. Why? You have x minus a upon root a. Now, if you
Yeah.
have added something, then you have made the fraction smaller, right?
Yes.
So this is smaller fraction, this is bigger.
Mm-hmm.
Now you have to introduce delta. You will say that the value which you are having, root x minus root a, if this is lesser than the epsilon to satisfy that definition, that means x minus a upon root a is less than epsilon. And if it is so,
Because, is it because x minus a over root a is less than root x minus root a?
yes.
And how do you get rid of root x again?
Where? Here, numerator.
Denominator.
Denominator, okay. Why x is not here? This is what you're asking.
Yeah.
So basically, what is it? I know this value is lesser than this.
Mm-hmm.
And epsilon is greater than root x minus root a.
Mm-hmm.
So that means this value, epsilon is greater than all of them. This value is greater than all of the this value is smaller than all of the denominators. So if denominators are having greater value, this value is going to be bigger And epsilon is greater than that. So epsilon is greater amongst all. Now, if you have substituted, you just take this root here. Now you need to choose something like delta, provided a limit. So initially you got x here, a here, a by 2 here. This is what you have assumed. Now you assume delta, which is bigger than this value. Okay? You have to verify whether it is bigger than this value or not. So for that, you are assuming that delta, in spite of the fact that it is just lesser, whichever value is lesser, you have to take that, the combination of epsilon and the value which you have got for x. You have to consider those two values and you take the minimum of that. And in spite of that thing to be considered, you have to say that, okay, delta is what? Greater. How? Because if you have x minus a, this x minus a, x is greater. So I know a is greater than x. So this negative value will also become positive because it is in absolute value.
Yeah.
So that means what is going to happen? I have assumed for this x is greater than a by greater than 0. I have x minus a, which is less than epsilon root a here. So this means square root of x minus square root of a is lesser than epsilon root a or epsilon. If it is lesser than epsilon and I have to consider delta as minimum of these two, So that means you can see that here a by x is greater than a by 2, right? Here
Yeah.
x is greater than a by 2. And here I have root x minus root a. I'm taking away something from root x. And this is making it lesser than epsilon root a. That means this satisfies the formal definition. What? That delta is making root x minus root a less than epsilon. I have considered delta to represent in these two forms. And final answer is this, which is in relation with a also giving me the lesser value. This is my upper bound.
Yeah. Okay.
So this is limit x tends to a, root x is root a. Is this fine?
Yeah, I don't fully get it, but I think I'm also gonna go through the working out that the teacher gave because that working out is a little bit shorter.
Shorter. Okay, you could have sent me that so that I could also see.
They just say that absolute value of x minus a divided by root x plus root a is less than or equal to 1 by root a times in the numerator the absolute value of x minus a. And that's less than epsilon.
Yeah, so basically they are also going through that process wherein epsilon has to be, you have to make it upper bound. You have to make the epsilon greater and rest of the things lesser, right?
So they've also just assumed that x is less than a.
Yeah, this assumption. I'm telling you, this is totally theoretical, abstract part. And herein you have to assume what you have to prove because you already know what is there as an answer. So you have to assume
Yeah.
that. Okay.
Okay, right. I see.
Yeah. So now, which question is left?
I think that was it.